Computer hardware has come a long way since the early days of computing. The first electronic computers, built in the 1940s, were massive machines that filled entire rooms. These early computers used vacuum tubes to process information, which made them incredibly slow and unreliable by today's standards. However, they laid the groundwork for the modern computers we use today. As technology advanced, vacuum tubes were replaced by transistors in the 1950s. This transition marked a significant leap forward in the miniaturization and efficiency of computer hardware. Transistors were smaller, faster, and more reliable, which allowed computers to become more powerful while also shrinking in size. This period also saw the development of the first integrated circuits, which further revolutionized computer hardware. The 1970s and 80s witnessed the advent of personal computers. Companies like Apple, IBM, and Microsoft played pivotal roles in bringing computers into homes and offices around the world. The introduction of microprocessors, essentially complete CPUs on a single chip, was a game changer, making computers even more accessible and affordable to the general public. Today, computer hardware continues to evolve at a rapid pace. Innovations such as solid-state drives, multi-core processors, and advanced graphical processing units provide unprecedented speed and performance. As we look to the future, developments in quantum computing and neural processing units promise to push the boundaries of what computers can achieve. Understanding computer hardware is crucial in today's digital age. Whether you are a casual user, a tech enthusiast, or a professional in the IT field, having a solid grasp of hardware components helps you make informed decisions. For instance, knowing the difference between a hard disk drive and a solid-state drive can influence your choice when upgrading your computer's storage. Moreover, understanding hardware allows you to troubleshoot problems more effectively. If your computer is running slow, identifying whether the issue lies with the memory, the processor, or the storage can save you time and money. Familiarity with hardware components also enables you to optimize your system's performance by making appropriate upgrades. For professionals, such as system administrators and IT support technicians, in-depth knowledge of hardware is indispensable. These roles often require diagnosing and resolving hardware issues, configuring new systems, and ensuring that all components work seamlessly together. Even software developers benefit from understanding hardware, as it allows them to write more efficient code that leverages the strengths of the underlying hardware. In an era where technology is deeply integrated into our daily lives, being hardware savvy also equips you with the skills to protect your digital assets. Knowledge of hardware security features, such as trusted platform modules and hardware firewalls, is essential in safeguarding sensitive information from cyber threats. A computer system is composed of several key hardware components, each playing a vital role in its operation. The motherboard, often referred to as the computer's backbone, houses the CPU, memory, and other essential circuitry. It provides the necessary connections and pathways that allow all components to communicate and function together. The central processing unit, or processor, is the brain of the computer. It executes instructions from software applications and performs calculations required for various tasks. Modern CPUs are incredibly powerful and can handle billions of instructions per second. They come in various models and configurations, with features such as multiple cores that significantly enhance performance. Memory, or random access memory, is another critical component. RAM provides temporary storage for data that the CPU needs to access quickly. Unlike storage devices, RAM is volatile, meaning it loses its data when the computer is turned off. Adequate RAM is essential for smooth multitasking and running memory-intensive applications. Storage devices, such as hard disk drives and solid-state drives, are responsible for permanently storing data. HDDs use spinning magnetic disks to read and write data, while SSDs utilize flash memory for faster performance and durability. The choice between HDD and SSD can impact your computer's speed, storage capacity, and overall user experience. The future of computer hardware is both exciting and unpredictable. One of the most anticipated advancements is quantum computing. Unlike classical computers that use bits, zeros and ones, quantum computers use qubits that can represent multiple states simultaneously. This capability has the potential to solve complex problems that are currently beyond the reach of traditional computing. Another promising development is in the field of neural processing units. NPUs are designed to accelerate machine learning and artificial intelligence tasks. As AI becomes increasingly integrated into various industries, from healthcare to finance, NPUs will play a critical role in enhancing the efficiency and effectiveness of AI applications. Advancements in storage technology are also on the horizon. Emerging technologies like non-volatile memory express and 3D XPoint promise even faster data access and higher storage capacities. These innovations will enable quicker boot times, faster file transfers, and overall improved performance for future computer systems. In addition to these cutting-edge technologies, we can expect improvements in existing hardware components. Processors will continue to get faster and more energy efficient. Motherboards will support more robust connectivity options, and memory capacities will increase. As these advancements unfold, staying informed about the latest trends in computer hardware will be essential for anyone looking to leverage the full potential of their technology. At the heart of every computer lies the motherboard, a complex circuit board that connects and coordinates all the essential components of your system. Think of it as the central nervous system of your computer, facilitating communication between the processor, memory, storage devices, and peripherals. The motherboard's intricate network of circuits and pathways ensures that data flows smoothly between these components. The motherboard's physical design plays a crucial role in determining the capabilities and limitations of your computer. The size and layout of the motherboard, known as the form factor, dictate the type of case you'll need and the overall compatibility with other hardware components. The processor, or CPU, is the brain of your computer. It executes instructions and performs calculations, handling everything from complex applications to displaying images. The CPU's speed impacts overall performance. Modern CPUs contain billions of transistors. These act as switches, processing data as electrical signals. Clock speed, in gigahertz, measures instructions per second. Multi-core processors handle multiple tasks simultaneously. Cache memory stores frequently accessed data, enhancing performance. Larger cache sizes can lead to noticeable performance improvements. Random access memory, or RAM, is your computer's short-term memory. It provides a temporary workspace for data and instructions. RAM is volatile, losing its contents when powered off. Think of RAM as a whiteboard for the CPU to jot down notes. Data is loaded from storage into RAM for quick access. This allows your computer to respond quickly and run smoothly. More RAM improves multitasking and performance. Adequate RAM is crucial for memory-intensive tasks. Section 4. Understanding different types of RAM. Over the years, several types of RAM have been developed, each with its own characteristics. Understanding these differences helps in making informed decisions for your computer. Dynamic RAM, or DRAM, is the most common type of RAM. It stores data in capacitors and needs constant refreshing. Static RAM, or SRAM, uses transistors, making it faster but more expensive. SRAM is used in CPUs as cache memory. Synchronous dynamic RAM, or SDRAM, synchronizes with the CPU's clock speed. DDR SRAM doubles data transfer rates by using both clock edges. Each DDR generation offers significant performance improvements. Section 5. The BIOS and UEFI. Getting your computer up and running. Before your operating system loads, your computer relies on BIOS or UEFI firmware. These interfaces control the boot process and enable hardware communication. When you power on, BIOS or UEFI initializes and tests hardware. This process, called POST, checks for errors. Once complete, it loads the bootloader from your boot device. The bootloader initiates the operating system loading process. BIOS and UEFI also allow you to configure hardware settings. Accessing these settings typically involves pressing a specific key during boot. UEFI offers a user-friendly interface and supports larger storage devices. It includes security features like Secure Boot to prevent malware. UEFI is gradually replacing BIOS in modern systems.
Storage devices, where your data resides. Storage devices are the custodians of your valuable data. They retain data even when the computer is shut down. Storage devices come in various shapes, sizes, and technologies. There's a storage device out there that fits the bill. Section 2. Hard disk drives, HDDs, the workhorses of data storage. For decades, hard disk drives or HDDs have reigned supreme as the workhorses of data storage, offering a reliable and cost-effective solution for storing vast amounts of data. These mechanical marvels have been the backbone of personal computers, laptops, and servers, providing a familiar spinning symphony as they diligently read and write data. An HDD consists of one or more spinning platters coated with a magnetic material. These platters, resembling miniature CDs, spin at high speeds, typically ranging from 5,400 to 7,200 revolutions per minute, or RPM. Data is written onto the platters using tiny magnetic heads that move across the surface, magnetizing specific areas to represent zeros and ones. The faster the platters spin, the faster the data can be accessed. HDDs offer a compelling advantage in terms of storage capacity. Due to their mechanical design, HDDs can accommodate multiple platters stacked on top of each other, allowing for terabytes of data storage in a relatively compact form factor. This makes HDDs an attractive option for users who require large amounts of storage space without breaking the bank. However, HDDs have their drawbacks. Their mechanical nature makes them susceptible to physical shocks and vibrations, which can potentially damage the delicate components and lead to data loss. Additionally, the moving parts within an HDD generate heat and noise, which can be a concern in noise-sensitive environments. Section 3. Solid-state drives, SSDs, the speed demons. In the relentless pursuit of speed and performance, solid-state drives, or SSDs, have emerged as a formidable contender in the storage arena. Unlike their mechanical counterparts, SSDs have no moving parts, relying instead on flash memory to store data electronically. This fundamental difference in technology translates into a significant performance advantage for SSDs. SSDs store data in tiny memory cells within NAND flash chips. These cells can be electrically erased and reprogrammed, allowing for rapid data access and transfer speeds. Without the need for spinning platters or moving heads, SSDs can retrieve data almost instantaneously, resulting in significantly faster boot times, application loading, and file transfers compared to HDDs. The absence of moving parts also makes SSDs more durable and resistant to physical shocks and vibrations. They are less likely to suffer damage from accidental drops or bumps, making them a more reliable choice for portable devices like laptops and tablets. Moreover, SSDs generate less heat and noise than HDDs, contributing to a quieter and more energy-efficient computing experience. However, SSDs come at a premium compared to HDDs. The cost per gigabyte of SSD storage is generally higher than that of HDDs, especially for larger capacities. This price difference can be a significant factor to consider when choosing between the two technologies, especially if budget is a primary concern. Section 4. Optical drives, CDs, DVDs, and Blu-ray discs. Optical drives, once ubiquitous in the computer world, have gradually faded into a more specialized role as storage technology has evolved. These drives, which read and write data using lasers and reflective surfaces, were once the primary means of distributing software, music, and movies. While their popularity has waned in recent years, they still hold relevance for certain applications. Compact discs, or CDs, digital versatile discs, or DVDs, and Blu-ray discs are the most common types of optical media. CDs, the oldest of the three, offer a relatively modest storage capacity of around 700 megabytes, suitable for storing audio files or small amounts of data. DVDs, with their larger storage capacity of 4.7 gigabytes for single layer or 8.5 gigabytes for dual layer, became the standard for distributing movies and software. Blu-ray discs, the latest iteration of optical media, boast even larger storage capacities, ranging from 25 gigabytes for single layer to 128 gigabytes for quad layer. This increased capacity, coupled with their support for high-definition video formats, made Blu-ray discs the preferred choice for distributing high-quality multimedia content. While optical drives are no longer standard equipment in many modern laptops and ultrabooks, they can still be found in desktop computers and external enclosures. They remain a viable option for archiving data, creating backups, and playing back legacy media formats. Section 5. External storage options, expanding your horizons. When your computer's internal storage starts to feel cramped, external storage devices come to the rescue, providing a convenient and portable way to expand your storage horizons. These devices connect to your computer via USB, Thunderbolt, or wirelessly, offering a versatile solution for backing up data, transporting files between computers, and expanding your storage capacity on demand. External hard disk drives, or HDDs, are a popular choice for external storage, offering a balance of affordability and capacity. These portable drives typically connect via USB and provide terabytes of storage space, making them suitable for backing up entire computer systems or storing large media libraries. External solid-state drives, or SSDs, offer a significant speed advantage over their HDD counterparts. These compact and durable drives connect via USB or Thunderbolt, providing lightning-fast data transfer speeds that can significantly reduce backup and file transfer times. However, external SSDs tend to be more expensive than external HDDs for the same storage capacity. Flash drives, also known as thumb drives or USB drives, are ultra-portable storage devices that fit conveniently in your pocket. These tiny devices connect via USB and offer storage capacities ranging from a few gigabytes to over a terabyte. Flash drives are ideal for transferring files between computers, storing presentations, or carrying important documents on the go.
Section 1. Keyboards, the traditional input workhorse. Keyboards, the stalwart companions of computer users for decades, remain an indispensable input device for tasks that demand precision and speed in text entry. From crafting emails and writing code to navigating spreadsheets and composing documents, keyboards provide a familiar and efficient way to translate our thoughts and commands into digital form. The ubiquitous QWERTY layout, named after the first 6 letters on the top row of keys, has become the de facto standard for keyboards worldwide. While its origins can be traced back to the days of mechanical typewriters, the QWERTY layout has endured the test of time, becoming ingrained in the muscle memory of countless typists. Keyboards come in a variety of shapes, sizes, and designs to cater to different needs and preferences. Ergonomic keyboards, with their contoured shapes and split layouts, prioritize comfort and reduce strain on wrists and hands during extended typing sessions. Gaming keyboards often feature mechanical keys with tactile feedback and customizable backlighting, enhancing responsiveness and providing an immersive gaming experience. Beyond the standard alphanumeric keys, keyboards also include a range of modifier keys, function keys, and navigation keys that provide additional control and functionality. Modifier keys, such as Shift, Control, and Alt, are used in combination with other keys to execute shortcuts, access special characters, and perform various system commands. Section 2. Pointing devices, navigating the digital landscape. Pointing devices, as their name suggests, allow us to interact with graphical user interfaces by controlling the movement of a cursor or pointer on the screen. From the humble mouse to the sleek trackpad, these devices have become essential tools for navigating the digital world, providing an intuitive way to select objects, open files, and interact with applications. The mouse, once a novelty, has become synonymous with personal computing. Its simple yet effective design, typically consisting of a body with one or more buttons and a sensor that tracks movement, has made it a ubiquitous input device. Mice come in various shapes and sizes, with ergonomic designs that prioritize comfort and gaming mice that boast high sensitivity and customizable buttons. Trackpads, commonly found on laptops, offer a built-in pointing device that eliminates the need for a separate mouse. These touch-sensitive surfaces allow you to control the cursor by sliding your finger across the pad. Gestures, such as pinching, swiping, and tapping, provide additional ways to interact with the operating system and applications. Touchscreens, which have become increasingly prevalent in smartphones, tablets, and even laptops, blur the line between input and output by allowing users to interact directly with the display. By touching the screen with your finger or a stylus, you can select objects, scroll through content, and even draw or write directly on the display. Section 3. Touchscreen technology. A direct connection. Touchscreen technology revolutionized our interaction with computers, enabling a more intuitive and direct connection. It made computing more accessible and engaging for all ages and abilities. Capacitive touchscreens, common in modern devices, use a layer of capacitive material that stores an electrical charge. Your touch disrupts the electrical field, registering the touch as a change in capacitance. Section 4. Ergonomics and accessibility. Designing for comfort and inclusivity. Ergonomics and accessibility in input device design are crucial as computers become integral to our lives. Ergonomic design optimizes comfort and reduces strain, while accessibility ensures usability for individuals with disabilities. Ergonomic keyboards promote natural hand posture, reducing discomfort and injuries. Ergonomic mice accommodate various hand sizes and grip styles, reducing wrist strain. Accessibility features cater to a wide range of disabilities. On-screen keyboards and eye-tracking tech offer alternatives for mobility impairments. Speech recognition software provides hands-free computing. Screen readers and magnifiers assist those with visual impairments. Braille displays offer tactile text representation. Input device design evolves with technology, enhancing ergonomics and accessibility. Future input devices like gesture recognition and brain-computer interfaces promise more inclusive computing.
Section 1. Beyond the conventional exploring specialized input devices. While keyboards, mice, and touchscreens have become synonymous with computer interaction, a fascinating array of specialized input devices cater to specific tasks and industries. These devices expand the horizons of what's possible, enabling us to capture real-world data, control complex systems, and interact with computers in novel ways. In the realm of design and engineering, digitizing tablets provide a natural and precise way to create digital artwork, technical drawings, and three-dimensional models. These pressure-sensitive surfaces, paired with a stylus, emulate the feel of pen on paper, allowing artists and designers to translate their creative visions into the digital realm with remarkable fidelity. For musicians and audio producers, MIDI, musical instrument digital interface controllers, are indispensable tools for creating and manipulating digital audio. These keyboards, drum pads, and control surfaces send MIDI data to music software, triggering virtual instruments, recording performances, and controlling various parameters of the digital audio workstation. In the world of gaming and simulation, joysticks, gamepads, and racing wheels provide an immersive and intuitive way to control virtual characters and vehicles. These devices often feature force feedback mechanisms that provide tactile sensations, enhancing the realism and excitement of the gaming experience. Section 2. Scanners. Digitizing the physical world. Scanners act as digital bridges between the physical and digital realms, allowing us to convert printed documents, photographs, and even three-dimensional objects into digital formats. These versatile devices use a variety of technologies to capture visual information and translate it into a language that computers can understand. Flatbed scanners, the most common type, resemble miniature photocopiers. They use a moving light source and a sensor array to capture an image of a document or photo placed on the glass surface. The scanned image can then be saved to a computer, edited, shared electronically, or printed. Sheet-fed scanners, as their name suggests, are designed to scan stacks of documents automatically. These devices use rollers to feed documents one by one past a scanning element, making them ideal for high-volume scanning tasks in offices and businesses. Handheld scanners, known for their portability, allow you to scan documents and images by moving the device across the surface. While they may not offer the same resolution and accuracy as flatbed scanners, they provide a convenient way to capture information on the go. Three-dimensional scanners take digitization to the next level by capturing the shape and dimensions of physical objects. These devices use lasers, structured light, or photogrammetry to create a three-dimensional model of an object, which can then be used for three-dimensional printing, reverse engineering, or virtual reality applications. Section 3. Cameras. Capturing moments and beyond. Cameras have evolved from simple photo devices to sophisticated tools in our daily lives. Smartphones now serve as primary cameras, featuring advanced lenses and image processing. Section 4. Microphones. Giving voice to the digital world. Microphones convert sound waves into electrical signals, essential for communication and recording. From dynamic to condenser to USB, each type serves unique purposes.
Monitors serve as our visual portals into the digital realm. From CRT to flat panel displays, monitor technology has evolved significantly. Key factors include size, aspect ratio, and resolution. The evolution of monitor technology focuses on image quality and energy efficiency. CRTs gave way to LCDs, then LEDs, and now OLEDs. Each advancement offers better visuals and thinner profiles. Resolution and refresh rate are crucial for monitor quality. Higher resolutions mean sharper images. Higher refresh rates mean smoother motion. Choose based on your specific needs. Section 4. Beyond monitors, projectors, and virtual reality headsets. Projectors offer large, scalable images for various settings. VR headsets create immersive experiences for gaming, training, and education.
Printers transform digital files into physical documents and objects. Inkjet and laser printers serve different needs from home use to high-volume tasks. 3D printers revolutionize manufacturing by creating objects layer by layer. Digital projectors are essential for presentations and home theaters. LCD, DLP, and LCOS technologies offer various benefits. Choose based on image quality and application. Haptic technology adds a tactile dimension to digital interactions. From smartphone vibrations to VR gloves, haptics enhance realism, used in gaming, medical training, and rehabilitation.
Computer hardware is constantly evolving, driven by innovation. Future advancements in AI, quantum computing, and nanotechnology will revolutionize our interactions. Staying informed is essential to leverage technology's full potential.